In today's video we're going to be looking at conversion graphs. Conversion graphs can be used to convert between different units of measurement like pounds, kilograms, miles and kilometres, or they can be used to convert between different exchange rates, so amounts of money in different currencies. Sort of similar to the currency conversion or the exchange rate lesson that we looked at last week. The difference here is we're going to be using a graph to do it. So sometimes in questions we might be given the graphs and then we can read values off the graph. Sometimes we might have to draw the graphs and we're given a little bit of information to help us with that. So we'll look in this video at examples of both of those. Okay, the example that we're going to start off with, when I can separate this paper, is converting between kilograms and pounds. Let me just pull that out a bit so we can see the page a little bit better. There we go. So we can see we've got a graph here that I've put on this page, and on the x-axis we've got kilograms marked, and on the y-axis we've got pounds marked. It has always struck me as a bit strange why we use LBS to represent pounds, and there is actually the reason why we use LBS for pounds is that LB is actually short for libra, for the Latin word libra. It's from in full libra pound. Libra is the Latin word for scales. Like if you think of the star sign Libra, the symbol for that is a pair of scales. Libra pounder was sort of like the scale of weight, so you would pay for things in how much they weighed. So that's where pounds comes from. It's like a weight of pounds. Okay, so we're converting between kilograms and pounds after that slight detour into history. The first thing we're being asked to do is convert between kilograms and pounds. So convert 1 kilogram into pounds. And if I have a look across my x-axis here, see that isn't quite written on, but that's actually 10. We've got 5 here. So 1 kilogram would be here. So that's where 1 kilogram is. I want to know how much that is in pounds. So what I would do is measure up there, see where my line meets that, and read off that value. Okay, and that is, well, this is 1, 2, 3, 4, 5, just making sure I've got the scale right going up there. So that would be 1 pound, 2 pounds, 3 pounds, so it's somewhere between 2 and 3 pounds. It looks closer to 2 than it does to 3. It's about 2.2 pounds. So 1 kilogram is 2.2 pounds. The next question is asking me to find 5 kilograms. This is very, very straightforward, isn't it? I'm looking at kilograms, so I find where 5 is there. I would go up here. We would usually use a ruler for this. I'm not doing, just so I don't block the screen with my ruler. That looks like it goes more or less exactly where that line going across is. That's the next line after 10. So because I know 1 square is a unit of 1 going up here, that's my scale, that's 11. So 5 kilograms is about 11 pounds. Here I'm wanting to convert 5 pounds into kilograms, so I don't want to go across here because that's 5 kilograms. I'm on this axis, the y-axis to start off with. I'm looking for pounds. We're finding 5 pounds. That's where 5 pounds is. So we'll still just go across on our graph. It's getting about to there. Let's read going downwards. Well, that's somewhere between 2 and 3. Looks closer to 2 than 3, so somewhere roughly about 2.3 kilograms. I'm not sure if that's exactly right. I'm not sure if I've read that as accurately as I can. Really, we'd want thinner lines in between there, and if we did this question as part of an exam question in maths, there usually would be a better graph drawn with more grid lines so we could read more accurately. I've not done that here just so that it's easier to see on the screen. But your answers usually will be able to go within a scale of sort of 1, 0.1, 0.2, or depending on what the scale on the x or y axis is. Okay, on question on part D, I'm still asked to convert pounds into kilograms, this time £8, so we said that was 5, 6, 7, 8. Just to make sure I know that's 8, I'm going to carry on my scale. That'd be 9, that'd be 10, yeah, that works out. So let's go across here. This is where it meets the y-axis, so again, I would be getting my ruler. Part of the reason it's really important for us to use a ruler for these is that if we don't, quite often what ends up happening is people's lines go wonky and they end up at a completely different place at the bottom from where they should be. So those lines need to be going straight down. Okay, and that one looks to me where it's between 3 and 4. It's maybe about 3.7, 3.8, let's say 3.8 kilograms. Okay, and finally, I want to convert 30 kilograms into pounds. Now, this is a little bit trickier. You can see our x-axis only goes up to 10 kilograms. So how am I going to get 30? Well, there's a few different ways. What we do here, if we're looking for something not on the axis, is we look for an amount that we can then scale up. So I'm going to do this 2 ways. The first way, I'm going to look at 3 kilograms. Hopefully you can already figure out why I might want to look at 3 kilograms. I go up here and read across. I think that's about 6.6. So I think 3 kilograms is equal to 6.6 pounds. Well, I wanted not 3 kilograms, I wanted 30 kilograms. So what have I done to this side of my ratio? I've multiplied it by 10. So I'd do the same to the other side. So I'm multiplying both sides of my ratio by 10. And we're using here now the same sort of ideas that we looked at when we did those currency exchange questions last week. So I'm saying 30 kilograms, I think, is about 66 pounds. Now, I did say there was another way of doing that question. The other way of doing that question, well, there's actually plenty of ways, but I could use some information I've already got. So we said up here that 5 kilograms is equivalent to 11 pounds. I can get from 5 kilograms to 30 kilograms by multiplying by 6. So if I'm multiplying this side by 6, my ratio, I need to multiply the other side of the ratio by 6, and we get 11 times 6 is 66 pounds. So either way there, I've got an answer of 66 pounds. Sometimes if we do those questions 2 different ways, we might get slightly different answers, but they should be more or less the same. In any case, what we're looking to do, if we're given an amount that isn't in the scale on our axis, so that we can't just read and find and then draw the lines and read off, then we need to find an amount that we can scale up, that we can multiply both sides of our ratio to get that amount. Okay, let's look at one more example with the graph already provided before we draw our own graph. So in this question, we're converting between, if I can get the whole of the page on, maybe not, let's pull this out a little bit further again. We're converting between pounds, so pounds sterling, as it says there, because it's the UK pounds. Other countries do use different types of pounds, and Japanese yen. Okay, and I'm using exactly the same ideas. So the first thing it asks me to do is to find out what £1 is in yen. So let's look at this scale. I'm not just going to presume the first line is 1. I'm going to check if it is. It looks like it might be. So that would be 1, 2, 3, 4, 5. I've got up to 5, so it is 1. So that's £1. We draw our line going straight up, and then our line going across, and that to me looks as if it's about 120 maybe, actually a little bit higher, maybe 130. So let's say 130 yen there, so £1 in yen would be 130 yen, and this is the symbol for yen, so like not what I've drawn there, so like a Y with two lines going horizontally through it. So £1 would be 130 yen. If I want to find out £5, find £5 on my axis that represents pounds. We draw our line straight up and we go across there, and I would say there that looks like it might be about 660, 670. So £5 I'm saying is 670 yen. Now actually, if I did scale both of these up, we'd see that those aren't consistent with one another. There's a difference between them. So one of those amounts isn't that accurate. We're not looking to get 100% accurate answers here. We're using our graph to read off the costs. Our accuracy depends on how well our graph's drawn. Here, my scale for my graph isn't that great, so my accuracy isn't going to be as good. Okay, if I want 500 yen in pound sterling, so this time I'm not reading off my pounds sterling axis, I'm reading off my yen axis. So that's 500 yen. So I want to draw a line across there and then going downwards, and I want to read off the amount that is. Again, we'd normally have more grid lines so I can read this more accurately. If I go £1, £2, £3, that's looking like it's about £3.80. So 500 yen, I'm saying, is £3.80. Now what we can also get on these questions are things that give us sort of problems in context. So like this one here, a game costs £3 in the UK and 350 yen in Japan. Where is it cheaper? Well, if I want to compare that, what I need to do is I need to look at the different prices in the different countries. So let's start off with UK, £3. How much would that be in yen? Well, that's where £3 is on the x-axis. Let's go up there. And that meets more or less exactly on that line, which is 100, 200, 300, 400 yen. So £3 is equivalent to 400 yen. Okay, and that's actually all I need to do, because I can see, well, if £3 is 400 yen and it's 350 yen in Japan, it is cheaper in Japan by, well, it's 350 yen in Japan. In the UK, if I convert the £3 into yen, it's 400 yen, so it's cheaper by 50 yen. Difference between that 350 and that 400. Okay, and I could have also converted 350 yen into pounds and got about £2.60, something like that, and said that it was cheaper or more expensive in the UK, because if we convert the 350 yen into pounds, it would be less than £3, so it would be more expensive in the UK. Okay, final question I want to go through is looking at what happens when we convert between different currencies and we're not given a graph, or different units of measurement and we're not given a graph to draw. And then we're typically asked to just draw a conversion graph. That's the first thing that the questions ask us. It says draw a conversion graph between pounds and dollars, given that £1 is $1.25. So I can start plotting that on. Actually, I don't want to do that at the moment because $1.25 is a little bit difficult to draw. Quite often what we want here is we want some coordinates that we can plot. We want a little table of values. So we've got that £1 is $1.25, well then £2, double 1, would be double $1.25, would be $2.50. £4, double $2.50 is £5. If I double that again, £8, double $5 is $10. And really, 3 points is all that I need here, because if I'm drawing a conversion graph like this, it's going to be a straight line if the things are in a ratio as they are here. Okay, so if it's consistent, like if we go up by £1, we go up by the same. If we go up so many, like £1, we go up $1.25. If we go up another pound, we go up another $1.25. That ratio never changes. So that's what gives me these straight line graphs. If I have 3 points, then I've got 2 points. I can draw a straight line between them, but I can also check using the third point that my straight line is right. If my third point doesn't lie on the same straight line as the other two, then I've made a mistake somewhere. So let's try plotting those points, see whether I've done this accurately. So £2, so this is my pounds, this is my dollars. So I'm going to £2 is $2.50. So that's going to be that point there. Okay, so notice again my scales are 1 up each time. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I do need to check that, because if they're not, and I didn't check that, I'd be plotting everything in the wrong place. So £2, $2.50, £4, and this is where £4 is, we said was $5, and £8, 5, 6, 7, 8, going across from 8 is $10. So those 3 points should lie on the same straight line. And we can see that they do. So that gives me confidence that I've drawn this, or I've done my calculations correctly. Okay, you also notice here this goes through the origin, because £0 would be $0. Not all of our conversion graphs would do. If they might not do if there's an initial cost for something. So a popular example of that is like a taxi journey, where there's an initial cost and then you pay a certain amount per mile that you travel. Okay, so we've got the graph, the conversion graph's drawn. We've also got a question here to look at. So Robert wants to buy a toy costing $10. I should say he has £6, not he was £6. He has £6. Does he have enough money? So it's $10. Let's have a look what $10 is. So I've gone across to $10. And I can see that the amount here travelling across is £8. So $10 is £8. He only has £6. Does he have enough? No. And we need to, it's not enough just to say yes or no there, we need to say why. So no, he doesn't have enough because he needs £8. So to get $10, he'd need £8. So it's just asking us there, it's giving us a question and expecting us to be able to look at the graph and see how can I use my graph to help myself with that question. Okay, and that's what conversion graphs look like. So try some questions on that. Let me know if you have any problems.